Good day, class. Good day, everyone. I'm sure everyone is doing great. Okay, before we dive straight to what we will be studying today, I'll be your teacher for today. I'm called Kome Makoge Alves. I'm a certified electrical engineer in Qatar from UPDA, and I've done PMP. I've done Six Sigma Yellow Belt, and I'm a professional certified Six Sigma professional as well. Today we'll be discussing mainly on containment works, containment systems, and power cables. I would not like us maybe waste much of our time by us introducing ourselves. Maybe probably we're gonna do that some other time. This is lesson number 18, which is containment system and power cables, cable tray, ladder, and UPVC ducts. Okay, before we dive into that, we have to first of all understand what is the containment system before we start doing calculations and selection of different containment systems that are used or that will be used for our designs, maybe in a residential building, a commercial building, or in the industrial buildings. Containment system, these are cable management system, which refers to as management or safeguard of electrical cables and many more. So when I talk of many more, I'm talking of different type of electrical cables. It could be fiber optic cables, but since we are limited ourselves to fiber cables, so I stopped at the electrical cables. So the next step is going to be the cable tray trunkings and cable ladder. So these are cable management system as well, or unit of assembly of units or sections and associated fittings. So these are a unit or assembly of fittings which are coupled or made up of different fittings forming together and make up a rigid structural system used to secure support cables and raceway. It is either PVC or steel. In that case, we call them galvanized ions or GI, and it should conform to BS 4674678. They are mounted either vertical or horizontally by using hung-on slabs on the walls or the floor by using supports. We'll move to the next slide, which is a picture of the cable containment system. So the first part, which is the cable tray, as you can see. The next is going to be cable trunking, cable ladder, and then we have a cable basket. So in this case, we will call this a perforated cable tray. The next slide now is going to be the different components that are used to couple or to carry out the containment works in the building. So we have the first is going to be the spring nuts. We have a roofing board. We have hexagonal head ball. We have hold down clamp. We have the channel. We have unifix. We have washers. We have threaded rod, and we have nuts. I really appreciate if you have any questions or any doubts. So we'll be discussing as time keep unfolding. It's very important, and I would really like my class to be an interactive session in such a way that we get to communicate among ourselves, so we get to understand exactly how all this works. So when we are carrying out designs, we know what we are doing, it fits or conforms to the requirement of the project. So the first part, which is a spring nut, this is used to connect to the channels. So we connect them to the channel and then hold a cable tray or the containment to the support. So the spring nut is used to hold both the containment to the support or the channel. So the next is going to be the roofing bolt, which will connect now to the spring nut while holding it to the channel. So we'll move to the hex head bolt. This is used to be clamped on the wall. We have the hold down clamp. Mostly these are used for to hold cable baskets to the support. We have the channel, which is explained already. We have Unifix, which is used to be drilled on the slab, on the wall, on the floor, to hold the supports or probably the channels. The washers, which are used to stand in between the roofing board to the channels, or the threaded rods to the channels. These are threaded rods which also act as support, which is used alongside with the channels. We have the nuts, which is used to be, we put them on the threaded rod so they get to hold the supports firm. We'll move to the next slide, which is a picture of a cable tray which is mounted on a soffit or on a slab. We have a cable tray trunking which is mounted on the soffit as well, and then we have the cable ladder which is mounted on the soffit. So here we have cable trays which are mounted on the floor as well as on the wall. We'll move to the next slide. I'm sure so far we don't have any questions. If we have, we'll just indicate so we get to move forward. The next slide is going to be fittings. So fittings can also be made up of different angles. So we have them either fabricated or ready-made. So in this case, they all depend on the project as well. So if the project specification states that all the fittings are going to be ready-made, as such, we are going to bring all our fittings ready-made. It will either be 90-degree, 60-degree, 45-degree, or 30-degree, and even T-bends. So we also have inside risers, we have outside risers, and many more. As you can see, these are the different graphics for the different fittings. This is a 90-degree bend. We have the inside riser. Now this is the outside riser. And then we have the T-bend. We have reducers here. And then we have the inside riser. Move to the next slide, which is the commonly used and the standard dimensions for cable tray, trunkings, and ladder. As you can see, we have 900 by 100, or 900 by 75, or 900 by 50. So if you see, the 900 will be the width of the cable tray, or the trunking, or the ladder, whatever. And then the by 100 will be the height of the cable tray. By 75 will also be the height of the cable tray, and by 50 will also be the height of the cable tray. These are just standard. These are standard dimensions that we could find them in the market. But again, they can still be customized based on the project specifications. The next, we have cable ladders. So we have 1,200 by 100 cable ladder. We have 900 by 100 cable ladder. We have 750 by 100 cable ladder. So it varies with their different dimensions. We have cable trunkings as well with their different dimensions also. So the note here, which I already explained, 900 by 100 cable tray, where 900 is the width of the cable tray, while the 100 is the depth of the cable tray. So I'll move to the next slide, which is the application. Mostly we find cable ladders, which are used for mostly in the substations, mostly in the MV room, LV rooms. We'll find cable ladders installed either in MV room or LV rooms, which are used to lay cables on top of them. So probably cables are leaving from the MV room or the MV panel coming to hit on the transformer, and then from the transformer goes to hit on the LV panel. So in this case, you mostly find cable ladders used for these applications. And it is being used as such due to the weight of the cable ladder. So if you look at the weight with respect to the weight of the different cables that are used in the substation, you notice that we use mostly 300 square cables, um, cables that are really large as such. We will hardly use cable trays that might maybe bend the cable trays or the cable containment over time. It's very important to understand. Then we have cable trays, which are used mostly for LV cables or every cablings, usually for distribution of power cables, either leaving from MDB or leaving from MDB to sub-main distribution board or from sub-main distribution board to distribution board. Mostly you find them even in sub-main distribution board going to distribution board, whereby we have feeder cables that are leaving from this end going to feed the other end. So move to the next slide, which is the cable trunking as well, also used for LV cable, ELV cables, such as fire alarm cables, BMS cables, lighting control cables, access control cables, and many more. So we'll move to the next now, this next point, which is noting, which is very important. For wall-mounted cables or ladder shall not exceed 1 meter. These are the codes that we should follow when we are carrying out the installation on site or probably carrying out designs in such a way that we have to put support from one point to another. It should not exceed 1 meter. This is very important. So when we are carrying out the installation works, we know exactly what we are doing. So for wall-mounted support brackets, so while for horizontal shall not exceed 1.2 meters from each hanger on the rods or on the different supports. We'll move now to the next slide, which is to calculate or choose the required cable tray or ladder. The first point, the reason why this is really necessary to choose the required size of cable ladder or cable tray is to enable the different cables that should be laid on that cable tray or the cable ladder, so they have sufficient spacing between them, and then also to make sure that we have a 20% space factor between the 20% space factor on the cable tray, and then we also have 20 spacing between cables to the next cable. So the first point is to choose what type is required, either perforated cable tray or ladder, based on the total weight of the cable. This is very important. The next point is measure the diameter of the highest cable applicable when selecting cable ladder, cable tray depth. This is very important when we are selecting the depth of the cable tray, which is the by which I mentioned. Like for example, we have 900 by 100. So the by 100 now will the height or the depth of that cable tray, which is the by 100, will be determined based on the highest overall cross-sectional area of the cable. The next point is going to be the total width of all cables, which will be equal to the total number of cables divided by the runs multiplied by the distance between each cable, which is, in this case, we talk of 20 plus the total cable outer diameter. Take distance between cables as 20 like I did mention. And then the weight of the cable tray is of 600 by 100 is 163 kilograms per meter. It's very important. So the next one is going to be an example which we have here, the 300 by 50 cable tray, where the width is going to be 300 while the depth is going to be 50. So you move down to the different dimensions as well. So We have 450, we have 900 as well. So this is 450. This is meant to be 450, not 400, 4,500. This is 450 by 75 cable tray. Okay, we move to the next slide, which is minimum radius for cables on cable tray travel/ladder. It's very important. So while we do designs and installation as well, we get to maintain the minimum bending radius. So in this case, if we have our design as or probably we have specification of the project skills that we should have ready-made, and this ready-made all the fittings, most especially the T bends, the 90-degree bends, all should be ready-made in such a way that we have a very good sliding of the cables and not causing the cables to exceed their minimum bending radius, which is very important. So this refers to the stress exerted on the radius of the cable while making a bend, which might either lead to a longer or shorter service life of the cable. The radius bend should be in reference of the overall diameter of the cable multiplied by a certain factor. So this factor now will be determined based on certain codes or probably on the specific project specification. In this case, we'll be looking at Karama, which it should not be less, it should not be less than 12 times the overall diameter of the cable. So find table below, which this I have to remove from here. We'll have to discuss that in the next session. So this is just an example on how to do various calculations. This is to prove that we will have an amount of cable. I will go back a little bit so we get to see what. Okay, this is the point here which we will discuss. Okay, question. Prove that the tag 16 900 by 100 cable tray can accommodate tag 17.1 cable tray. This is an example which is very important. So if you are able to prove this, you'll be able to do various calculations and to select different sizes of containments that will be used for different applications in buildings. So we have a graphic here. We show our cable tray and the tag, which is 16. Here the dimension of 16. So it can accommodate in 17.1, as you can see here. So if we move down, you see this is tag 16. These are the different cables that are being laid in tag 16. And then 17.1, this is the cable that is laid in tag 17.1, which is 4 square cable and a single PVC wire which is used for earth. So this is a calculation I've done for tag 16 when overall diameter is not given. Is really good. You can go through 17th edition of IET wiring regulation taken from 5.4G. So all this I've done as well. So I got my total overall diameter of 333.3. So for tag 17, I have a total of 23.9. So tag 16. So I have total overall diameter 333.7. Total number of runs, which is 13. Space factor, which is 20 mm. So 20 mm multiplied by 13, which is the total number of runs of cable. So we result to 360 mm. So the width is, so we have a space factor. So we came up to a height of 40 mm. Tag 17, we did the same. So we came to this total width of 52.68. So adding 17.1 and tag 16. So we'll add both. We have 900 by 50 mm cable tray. So referring to ICMS, so you can go to any manufacturer. So IC note catalog 2018 for selection of sizes. Go to download catalog. You can download the catalog and then you see how to select the different sizes based on the this is depending on the manufacturer which is being used on that project. But as stack 16 is 900 by 50 mm and 900 by 50 but 900 mm is greater than 765, so it is acceptable to join both 17.1 to stack 16. It's very important. So I'm sure it's really clear to everyone, and also in the next session or in the next class, we will discuss more and do some calculations again. Thank you very much.